Hello students. We just covered algebraic expressions and now we're going to start looking at algebraic equations. And basically, when two algebraic expressions are equal, they form an equation. A few examples of equations include 3x minus 2x equals 8, y minus 2 equals 5, and 3a equals 15. We can have much more complicated equations, but those are just some simple examples for right now. We can solve an equation for the variable by isolating the variable on one side of the equation, which is something that we're going to do in just a moment. And a solution to an equation is a number that we can substitute in for the variable and make the equation true. You've probably solved equations before. Right now we're going to review the rules that tell us what we're allowed to do when solving equations. We're going to look at some simple examples, and then we're going to look at some slightly more complicated examples. But first, let's talk about the rules. So we have several rules for solving equations, and each of these rules tells us something that we are allowed to do, something that we may do. So one thing that we may do is simplify either side of the equation. So for example, if we have 3x minus 2x equals 8, on the left-hand side we have like terms and we can combine those. 3x minus 2x equals x, and so this equation becomes x equals 8, and that is our answer because we've got x isolated on one side. So the solution here is x equals 8. If you want, you can check by plugging it in. If we plug in 8 for x, that's going to be 3 times 8 minus 2 times 8. And we hope that that equals 8. We want it to be a true equation. 3 times 8 is 24, minus 2 times 8 is 16. And it is true that 24 minus 16 equals 8, so we know that 8 is the correct solution. If we tried plugging in another number, it simply would not work. So we can simplify either side of an equation. The next thing we may do is we may add or subtract the same quantity on both sides. This is another property that we're allowed to do. If we look at the other example that we had, y minus 2 equals 5, remember our goal when we're solving an equation is to isolate the variable on one side. So we want to get y alone. What else is on the same side of this equation as the y? Well, there's also this 2 on that side, and the 2's being subtracted from y. To get rid of it, we have to do the opposite. What's the opposite of subtracting 2? Well, that's adding 2. But the rule says we need to do the same thing to both sides. So we're going to add 2 on the left and right-hand sides of that equation. When we do it on the left-hand side, the 2's cancel. Negative 2 plus 2 is 0, and we're just left with y. On the right, 5 plus 2 is 7, and now we have y equals 7, which gives us the solution. We know that 7 is the number we could plug in to make that true. And in fact, if we check, plugging in 7 for y, 7 minus 2 does equal 5, so we know that that is correct. All right. We have 2 more properties that we're allowed to do. We can simplify either side, we can add or subtract the same quantity. We can also multiply or divide both sides by the same non-zero quantity. All right, so if we have the equation 3a equals 15, We want to get the a alone. Now what's happening to the a is it's being multiplied by 3. What's the opposite of multiplying something by 3? Well, that's going to be dividing it by 3. So we're going to divide both sides of the equation by 3. On the left, 3a divided by 3 is a. On the right, 15 divided by 3 is 5. And now that we have a alone, we have our solution, a equals 5. Oops, that was rule number 3, not rule number 2. Sorry for that. And we have one last rule. This rule says that we may interchange the two sides of an equation. This simply means if we have the equation 4 equals x, we're allowed to rewrite this as x equals 4. You don't have to rewrite it. It's perfectly fine to leave an equation as 4 equals x, but we want to have a list of things that we're allowed to do, and this is something that we're allowed to do, so we want to put it on the list. So we can switch both sides if we want. Now that you've learned the basics, I want you to click on the link below, which should give you at least, I think, 8 or 9 different examples of worked out problems where we're solving equations. You can go through them one at a time, and once you feel like you've gotten the hang of it, I'd like you to try the problem yourself and then watch the video afterwards to see if you're getting it right or not. This is a good way to make sure that you're learning what's going on and you're able to apply these rules yourself.